Good morning. Happy Wednesday. I hope everybody is staying warm and dry. And I keep telling myself it's just rain, it's not snow. But man, it's chilly out there today. So we have the fact that it's Wednesday to keep us warm. It's, almost done week 8. We have today's class and tomorrow's class, and then we are done week 8 because we do not broadcast on Fridays. If you're just tuning in, my name is Kobe Flatt, and for the next 50 minutes, we're going to be going through the MAP4C Grade 12 Foundations for College Mathematics course. Every Monday to Thursday between 10 and 11, I go through the IL course material for MAP4C. This course has 20 lessons, and we've been working the last 8 weeks our way through the course. The beautiful thing about adult education is you can take this independent learning course, do it at your own pace, do it whenever you've got time, do as much as you can when you can. But the radio Zoom classes are here to help keep you on track. They're here to give you those deadlines, that time management skill, which is so important for if your sights are set on college. This is a college prep course. We want to give you those skills as well as the concepts needed in this curriculum material. So today we are on week 8. We're going to look at lesson 19, which leaves tomorrow for lesson 20, and that wraps up our course. Next week, week 9, we're going to use for review. So if you feel like it's been a long time of math, you're right, it has. We looked at lesson 1 way back at the beginning of September. And because it's a college course, there is an exam. You'll want to refresh your memory on the concepts that we learned way back at the beginning of September. Tune in next week to go through all of Unit 1, all of Unit 2, 3, and then a nice refresher of Unit 4 to wrap up what we're doing this week. Yesterday we looked at lesson 18. We talked about the sine law and how the sine law is the relationship between the ratios of the sines of the angles of a triangle and the lengths of the opposite sides. We learned to use the sine law when you need an angle and the value of its side opposite, a second angle, and the need to find its unknown opposite side. Or you can use the sine law when you need an angle and the value of its side opposite, a second side, and the need to find its unknown opposite angle. That's when we want to bring in the sine law. Now in lesson 17, we took 2 days to go through what is sine, cosine, and tangent. We learned that we can use the acronym SOHCAHTOA, which relates to sine, cosine, and tangent, when we're working with right triangles. The sine law helps us to find angles and side lengths in oblique triangles, those triangles that are not a right angle. Today on lesson 19, we are looking at the law of cosine. We're going to explore the law of cosine, compare how it relates to the law of sine, and better understand how to use cosine to find unknown sides and angles. Our learning goals for today are that we will be able to draw and label triangle angles and sides. We can interpret information and draw diagrams based on that information. We will use the cosine law to find an unknown side or angle. I'm hoping today to put a little more emphasis on the importance or the usefulness of diagrams. We touched on it yesterday, but today I'm going to show why we want to work on that second learning goal of interpreting information and drawing diagrams based on that information to help. Yesterday we saw how the law of sine can sometimes give us 2 answers. So if you can visualize and picture which way that side swings, and use your critical thinking of, is this an oblique angle, obtuse angle or acute angle, then it will help us to know whether we're on the right track. We're all working in oblique triangles in lesson 18 and today's lesson 20. So quickly, because I'm already tongue-tied, our keywords, when we talk right angle, we're saying that angle is 90 degrees. That's that perfect square. A right triangle is a triangle with one right angle in it. Now, the other angle could be an acute angle, which is an angle that's between 0 and 90 degrees. Remember, acute little, it's tiny, it's cute. It's between 0 and 90 degrees. It's less than 90. An obtuse angle is a large angle. It's grand, it's obtuse. It's between 90 and 180 degrees. It's larger or greater than 90 degrees. We've been speaking of the hypotenuse, the opposite side, and the adjacent side as we're labeling our triangles. The hypotenuse is always opposite the right angle, and it's the longest side. The opposite side is the side that's directly opposite or across from the marked angle, that relevant angle, the angle that's been highlighted. And that leaves the adjacent side, which is the side that's beside or next to that marked or relevant angle. We reviewed Pythagorean theorem to help us find the length of a side using Pythagorean theorem's formula of a squared plus b squared equals c squared. We've talked about the different types of triangles, that we have the right triangle has one angle that is 90 degrees. An acute triangle has 3 acute angles. All angles are less than 90 degrees. An obtuse triangle is a triangle that has one obtuse angle. Then to further categorize, the right triangle has at least one 90 degree, whereas an oblique triangle is any triangle that is not a right triangle. So that could be an obtuse triangle or an acute triangle. We've been talking about trigonometric ratios. We've talked about sine, cosine, and tangent, looking at the acronym SOHCAHTOA to help us remember when we use sine, we have the opposite and hypotenuse. When we use cosine, we have the adjacent and the hypotenuse, and tangent deals with the opposite and the adjacent. When we need to work our way through them, sometimes we have to cancel something out to identify or isolate our variable, and that's when we use the opposite operation. The opposite operation in our trigonometric ratio is the inverse ratio. You can use the inverse ratio, inverse sine, inverse cosine, and inverse tangent to determine the measure of an angle when its trigonometric ratio is known. So if you want to find acute angle A in right triangle ABC, you would use inverse sine A to give you angle A, inverse cosine of cosine A to give you angle A, or inverse tangent of tangent A to give you angle A. Yesterday we talked all about the sine law. We looked at the cosine ratio back in lesson 17 on page 17 of unit 4. We know that the cosine ratio can be used to calculate an unknown angle or an unknown side in a right triangle. To find either of these unknowns, we use the adjacent side and the hypotenuse. Remember, ka of our SOHCAHTOA is cosine equals adjacent over hypotenuse. So that sine ratio then, cosine always uses the hypotenuse and the adjacent sides of a right triangle. Cosine equals adjacent over hypotenuse. The cosine inverse then, cosine function, cos, that's cos, takes an angle and gives us the ratio adjacent over hypotenuse. But inverse cosine goes the other way. It takes the ratio adjacent over hypotenuse and gives us the angle. So remember that circle diagram again to complete the circle. If we have an angle, we can use cosine to find the ratio adjacent over hypotenuse. But if we have adjacent over hypotenuse and we want to find the angle, we use inverse cosine. With that refresher, let's look at the cosine law today. Today's cosine law is finding the third side of a triangle when two sides and a contained angle are known. To find an angle, measure when the length of three sides are known. Now we're talking about oblique triangles. We're not talking right triangle. The cosine law is used to find the third side of a triangle when two sides and a contained angle are known, or to find an angle measure when the length of all three sides are known. Sort of like Pythagorean theorem, it relates the squares of the lengths of the triangle. Pythagorean theorem, however, only works for right triangles, whereas the law of cosines works for any triangle. Yesterday, when we went through the law of sines, we were talking about how there is an angle between or contained between two sides and how you have to be careful because one of the sides can swing. We're building off of that and using similar principles for the law of cosine. On page 38 of Unit 4, you will see we start to talk about contained angles more. The contained angle in a triangle is the angle between the two given sides of a triangle. So if we know two given sides and in between you have a known angle, that is referred to as a contained angle. So on the board in front of me I have a diagram, triangle ABC. We know sides B and side C, and we know angle A. Angle A is sandwiched between sides C and B. That is a contained angle. So you can think of the cosine law being used for situations where you have SAS, that side angle side, that sandwich, that contained angle. You can also use cosine law when you have SSS, side, side, side. When we're talking side angle side, I have a diagram on the board in front of me that says, again, we have triangle ABC. We know angle A, side B, and side C. We can use, much like that Pythagorean theorem for right triangles, we can use the formula a squared equals b squared plus c squared, but minus 2 side b side c cosine A. This is the formula that we can use to find the length of side A. So if we plug it in, side A is what we're trying to find. So we say a squared equals, side B is 8, so we plug it in or we substitute for. We say 8 squared plus side C is 11, so we say 11 squared. And then we subtract 2 times 8, and we have in brackets, times 11 in brackets, times cosine A, which is 46 degrees. We can manipulate this formula, much like we did with Pythagorean theorem. We can manipulate so that we can identify directly which side it is that we're trying to find. We can use a squared equals b squared plus c squared minus 2bc cosine A. But the important thing to remember is, and we're going to flip the formula around so you can see how it works, but when you're trying to find side A, you always have to have its cosine on the opposite side. So if our unknown side is on the left of the equal sign, our angle will be on the right. So you'll see how we break that up and work that out. Now, we said you can also use cosine law when you have side, side, side. If you don't know any of the angles, you can still use c squared or a squared plus a squared equals b squared plus c squared minus 2bc cosine a. And I said we can flip that formula. We can work it out to, if we want to just find c, cosine c, we can say c squared equals a squared plus b squared minus 2ab cosine c. The key is to make sure that it's balanced, that the one that you're trying to identify is the side and angle are balanced on either side. And I'll explain that further as we go through it. All right. The law of sines allowed us to solve triangles that are side angle angle, angle side angle, and side side angle. So that looked like if we had triangle ABC and we knew either side angle angle or angle side angle or side side angle, we could use the law of sines, which was, if you remember, when you can't solve using sine rule alone because you don't have a right triangle, we use side A divided by sine A equals side B divided by sine B equals side C divided by sine C. We could use that law of sines to identify a missing angle or a missing side if we had that side angle angle, angle side angle, or side side angle. You could not have used the sine rule alone. It requires one ratio to be intact. We had to at least know one side and its corresponding angle in order to use the law of sines. The law of cosines, we don't need to have a matching set, so to speak. We can solve for A if we don't know cosine A. We can solve for B if we don't know cosine B. On the board in front of me, I have a graphic that shows you that manipulation of the formula so that you can identify the specific side, for instance, that you're looking for. We know it's a squared equals b squared plus c squared minus 2bc cosine a. If it was b we wanted to find, and we used the formula a squared equals b squared plus c squared minus 2bc cosine a, and it was b that we wanted to isolate, we would essentially subtract it out because we have to do the opposite operation. That would cancel it out, but whatever we do to one side, we have to do to the other side. So we would end up with b squared minus b squared. Cancel it out, leaving us c squared minus 2bc cosine a. But we had to move it to the other side, so now we have a squared minus b squared. We would then get rid of our a squared, subtract that out, move it over. We would have to then subtract out our -1 to make it a +1. And it's this whole rigmarole of crossing out, canceling it out, switching to get us essentially b squared by itself, would equal c squared plus a squared minus 2ca cosine b. Or if we wanted c squared, we would do a squared plus b squared minus 2ab cosine c. So if we worked the whole problem all the way through, you would see that we would end up with these three. You can take a picture of this, use it as a cheat sheet. It can also be, your exam comes with the formulas that you're going to need, so it's there, but if you want to use this for solving your key questions, feel free. When we deal with the law of cosine, we can use side angle side, which is telling us that in any triangle, given the lengths of two sides and the measure of the angle between, remember that contained angle, we can use the cosine law to determine the length of the third side. Let's try it. Let's put all of that theory and those formulas and the switcheroos around to help us calculate. Using cosine rule, substitute and calculate the following triangle. So here we have triangle ABC. We know side B, we know side A, and we have angle C. We want to find side C. In order to find side C, we can use that cheat sheet of, rather than working our own way through a squared equals b squared plus c squared minus 2bc cosine a, we're just going to jump right down to c squared equals a squared plus b squared minus 2ab cosine c. We're going to use that one so that we don't have to do all the shuffling around. We can simply substitute or plug it in. So we're going to use that cosine law, the formula for, to help us find side C. C squared equals a squared plus b squared minus 2ab cosine c, because we have that balance. Let's plug in what we know. C squared, or C, is what we're trying to find. A is 14.1 squared, plus B is 8.9 squared, minus 2A is 14.1. Remember to keep your brackets intact, because if we wanted to plug this right into our calculator, we could, as long as we are organized. And the last part is times cosine C, which is 67 degrees. So we could type it directly into our calculator. Let's work through it first using our order of operations, and then we'll see how it matches. C squared equals, let's solve. What is 14.1 squared? We get 198.81. Okay, then we add, what is 8.9 squared? 79.21. And then we subtract. We want to know what is 2 times 14.1 times 8.9. We get 250.98 cosine 67. So if we want to solve that, we can either carry everything else down that we're not using right now, and we can find out what is 250.98 times cosine 67. We get 90.5 let's say 0.66. We'll take it to 3 decimal places. And then we could find what is c squared equal to. We can type in 198.81 plus 79.21 minus 90.066. We are left with 198.81. Oh, not minus. We were supposed to do plus. There we go. Plus 79.21 minus 98. Good golly. Good thing it's Wednesday and we're almost done this week. This is why it's important to check your work. There we go. We have c squared equals 179.954. But we're not done. We want to get c by itself. We don't want to find what is c squared. We want to find what is c. So we need to get c by itself. Right now it's squared, so we do the opposite operation and we find the square root. That cancels out our squared, but whatever we do to one side, we have to do to the other. So by canceling out our squared, we are finally left with just c, which is what we're trying to solve. But we need to find what is the square root of 179.954, and we get c equals 13.4. So we now know side C. Now, if you didn't want to do all of those steps, you could simply go back to where you first plugged it in. We can go back to our very first step and we can just type it directly into Desmos. We can say 14.1 squared plus 8.9 squared minus 2, and then make sure to use your brackets. 14.1, close the bracket, open a new bracket, 8.9, close the bracket, put in cosine 67, close the bracket, and we get 179.954. So we get to skip all of these middle steps where there's the potential to get answers wrong. As you saw the way that I was writing it in, I wrote it in wrong. And so to avoid those calculation or writing mistakes, you can save yourself by just skipping down, typing it directly into your calculator, and it brings you to c squared equals 179.954. And then from there you still have to do your square root of. We can do the square root of and get c equals 13.4. So you can see it's the same. It's a nice way even to check your answers, to check that you did it right. If I had stuck with my wrong numbers and wrong operations, I had said minus instead of plus, and then I put 90 instead of 98, this is a good way to say, oh, look, the answers didn't match. Where did I go wrong? And you can go back and fix. It's a good way to check your mark, check your work, and you can adjust as needed. Now that we have found the side, the next question asks us to solve for all angles. Now there are multiple ways you can do this. Based on yesterday's lesson, now that we have an angle and its opposite side, we could use the sine law. We could do our A over cosine A equals B over cosine B equals C over cosine C. Now, we need to have one complete angle, so we have to at least use C now that we have found side C. And then we could use that to find angle A if we wanted to do A over cosine A equals C over cosine C. We could work that out, cross multiply, work through to solve for B, and then do it again to solve for A, and then do it again to solve for B. You could. You have enough information to do that now. You can also use the cosine law that we are working on. So because we did the law of sine yesterday and we worked through that, let's practice working through the law of cosine today. Say we want to find angle A. Let's make angle A our first angle that we want to find. If angle A is what we want to find, we're going to use A squared equals B squared plus C squared minus 2BC cosine A. We're going to plug in what we know. We know A squared. A is 14.1 squared. We know B is 8.9 squared. We now know C is 13.4 squared minus 2B is 8.9 and C is 14.1, and it's cosine A that we want to find, so we're going to leave that at cos A. And now we can solve the rest. We can say what is 14.1 squared to find that it is 198.81. And then we can find 8.9 squared is 79.21 plus 13.4 squared equals 179.56 minus, and we can find 2 times 8.9 times 13.4 is 238.52 cosine A. We can keep that. And then we can solve farther. We're going to bring down our 198.81, and we're going to say what is 79.21 plus, make sure it's plus this time, Kobe, plus 179.56. Why can't I hit that? Oh, 56. There we go. That gives us 258.77 minus 238.52 cosine A. So we're getting closer. We really want to get that cosine A alone. We want to isolate that cosine A. I always like to have my unknown on the left-hand side. So I like to work it out that I have my unknown on the left. Because that's the way I want to work it out, I am going to get rid of it from the right-hand side by canceling it out. Right now it's minus 238.52 cosine A, so I'm going to add 238.52 cosine A, which cancels it out. But whatever I do to one side, I have to do to the other. So I have to add 238.52 cosine A, which leaves me 198.81 plus 238.52 cosine A equals 258.77. All right, I have my unknown on the left-hand side now where I like it, but now it's attached to the 198.81. So I have to get rid of that 198.81. By getting rid of that, I'm going to subtract 198.81 to cancel it out. But then I have to do that to my other side, minus 198.81. So that leaves me on my left-hand side, I have 238.52 cosine A equals 258.77 minus 198.81. And now I can actually solve that. I can say 238.52 cosine A equals, and I can solve what is 258.77 minus 198.81. I get 59.96. Now I can isolate cosine A. Right now it is multiplied with the 238.52. So I'm going to cancel it out by doing the opposite operation and dividing out 238.52. That leaves me with just cosine A on my left side. But remember, whatever I do to one side, I have to do to the other. So I have to say 59.96 divided by 238.52. So when I type that into my calculator, 59.96 divided by 238.52, I am left with no room. All right, I'm going to go over here. Cosine, let's do in blue, cosine A equals 0.2514. Now I'm so close. I've got cosine A, but I just want the A. When I want to get A by itself, I have to use the inverse, the opposite operation. I have to do inverse cosine to cancel it out, but that means I have to do inverse cosine on the right-hand side so that I can get A by itself. We're almost there. A equals, go to my function, do inverse cosine, 0.2514. I get A equals 75 degrees. So I finally did a lot, worked a lot, canceled out a lot, switched a lot, and I got 75 degrees for angle A. Now with this information, I could use the law of sine to find angle B, because remember the question says solve for all angles. All of that work just got us one more angle. But the nice thing is from here I can either use the law of sines, or if you remember our little cheat, the measure of a triangle, all of the angles, has to equal 180 degrees. Right now, 180 degrees minus, I have 67 degrees, and I just found 75 degrees. So I can say 180 minus 67 minus 75 gets me angle B equals 38 degrees. So I can make the last step really easy because the sum of all of the angles in a triangle has to equal 180. If they all equal 180, then my last one has to be 38 degrees. So there are lots of different ways you can solve for an angle or a side. If you don't know, you can use, in an oblique triangle, the law of cosine, the law of sine, and once you find one, maybe you can switch to the other, but it's completely your preference. So there was a lot that happened in here. I'm going to see, because this one is a little bit more lengthy, I just want to make sure we get everything in so that we can wrap up on time. What do I have left? Let's look at side, side, side. When you have side, 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 you can use the cosaw line to calculate the measure of an angle when you know the lengths of all three sides. So let's try one of these before we move on. It says, using the cosine rule, substitute and calculate the following triangle. We have triangle ABC. We know all three sides. Side A is 22.5, side B is 16.7, and side C is 18.9. We can find the angle of whatever one. We can find angle A. Using our formula, if we have A squared equals B squared plus C squared minus 2BC cosine A. Remember, we can actually flip and rearrange, if you will. We want to get just A by itself. We can move him over to the left, making him a positive 2BC cosine A equals, and then we would have to subtract out our A squared. Excuse me. And move him over to the other side, making our new formula B squared plus C squared minus A squared. So we can have 2BC cosine A equals B squared plus C squared minus A squared. We could work them that way. If we want to work through the steps, we can do that as well. A squared equals B squared plus C squared minus 2BC cosine A, and plug in what we know. A is 22.5 squared equals B is 16.7 squared plus C is 18.9, and then square it, minus 2B is 18.9 times, nope, that's a lie. There we go. B is 16.7. 16.7. C is 18.9 cosine A. Or, for the sake of, to show you simultaneously to save time, we can use our formula 2BC cosine A. So if I do 2B is 16.7, C is 18.9, cosine A is the one that we're trying to find, equals, and then I say B squared. B is 16.7 squared plus C is 18.9 squared minus A is 22.5 squared. So we're going to sort of have two tracks going on here. I would do them side by side, but I don't have enough room, so I'm going to have to do them one on top of the other, but I'll try to color coordinate them so that you know. Let's find what is 2 times 16.7 times 18.9. Oops. There we go. We want to make sure that our brackets are in the right place. We get 631.26 cosine A equals, and then we can solve for 16.7 squared plus 18.9 squared minus 22.5 squared. We get 129.85. We really want to get cosine A by itself. Right now it's multiplied, so we're going to divide out 631.26 to cancel it out, but what we do to one side, we have to do to the other, and that leaves us with cosine A equals 129.85 divided by 631.26, which means cosine A equals 0.205. Let's go to 7. Now remember, I want to get cosine out of the way, so I have just A. So I'm going to use inverse cosine, but that means I have to do inverse cosine. And let's do 0.2657. A equals the inverse cosine 0.252.057. Now that I look up top, should be 2, 0, not a 6, that's a 0, 5, 7. I get A equals 78 degrees. So angle A, that's A, equals 78 degrees. Now I can repeat to find one more angle. I could use the sine law because I have enough information for one ratio. I have A as a complete ratio. So I could do sine A divided by side A is equal to sine B divided by side B and solve for sine B. I could use the cosine law. I could use the cosine law to find now angle B again through switcheroo, find 2AC cosine B, but we are running out of time, so play around with that if you want. See if you can find another angle using both the sine law and the cosine law. Try your hand at both of them. We are going to move to term of the unknown side length. Oh my gosh, there are so many. I was super ambitious to try to get all of those different practice questions in, those examples in. We are out of time. It's important to note that the cosine law, there we go, is used to find the third side of a triangle when two sides and that contained angle are known. Or you use the cosine law to find an angle measure when the length of all three sides are known. Remember that contained angle is the angle between two given sides of the triangle. You can mix and match. If you have to find all angles or solve for the whole triangle, they want to know all three sides and all three angles, you can mix and match. You can use the cosine law to help get an angle or a side, and then once you have a complete ratio, you can move over to the sine law to solve. Once you have two of the angles, you can use the knowledge of the sum of a triangle needs to equal 180 degrees to find that third angle. Lots of exciting ways to do it. Trigonometry is almost done. We have one more class tomorrow where we're going to wrap it all up, do trigonometric ratios a little bit more and problem solving, and then that is the end of our course material. Tune in again next week for the unit reviews, and you'll